Just a short video to explain something specifically about ZKTeco readers and anti-passback, as we often have inquiries for turnstiles, for example, where the client would like to use SpeedFace Minis, MB600s, and in fact any of the other biometric readers, ZK readers that are standalone readers, and they want them to work with anti-passback. And the misconception is that you'll be able to connect these readers, and what happens is installers, resellers purchase these readers and then they can't get anti-passback working, and then they come back to us and we have to explain to them that they'll have to purchase controllers because it's only with a controller that they can have anti-passback. It must have been close to 2004 when I requested the change to the originally it was the F4 reader or the F18 reader, where we got them to work with anti-passback in the firmware itself with a slave reader. But other than the F18, which is still sold today, there are no other devices that support anti-passback. So I asked a question to AI, and this was the response, and I think this is a much better response than my explanation over here, which you can pause and read as far as my question goes and my validation with AI. And this is the response I got back. Okay. So the controller requirement, okay, for models like the MB600 and SpeedFace Mini, as well as all other devices between you and me, which do not have built-in anti-passback algorithms, you do need an external controller such as a C3 or an inBio series that uses an interface typically like the Wiegand to enforce anti-passback rules. In contrast, some models like the F18 and only the F18, because the F4 Vista is no longer manufactured, have onboard anti-passback functionality and do not require separate controllers for that feature. Okay, so users use a database setup in a system where an external controller is managing anti-passback. You configure the controller with your user database, and then these enroll IDs are then synchronized to each of the connected readers. This ensures that every part of the system, the controllers and the readers, are all enrolled with the enroll IDs. Okay, so they all match, so that you can enforce the anti-passback rule via the controller. So the controller is what actually controls the door, and not the biometric reader. The biometric reader is basically just storing the algorithms, the fingerprints, the cards, and the facial, if you've got any of those three combinations, as well as PIN and code. And then they will then send the enroll ID to the Wiegand interface, which will then decide whether you're in or out. Okay, and on the logic, the local biometric processing, the biometric verification, whether it be face or fingerprint matching, is performed locally on the reader. The controller doesn't supply biometric data to the reader. This means that even though the controller holds the centralized user IDs for anti-passback logic, the reader must have the biometric template stored locally so that it can then identify that person in real time. In practice, this results in enrollment being performed and synchronization to both the controllers and the readers. What I also recommend that you can do, especially if you're using older software, is that you could pre-configure the controller, and you could use a cheap controller like the C3, which doesn't support biometrics with slave readers, and you could use that with the Wiegand interface, and you could pre-set up, example, 1,000 enroll IDs, and then you can use a batch from that 1,000 enroll IDs and connect the standalone readers together with the software, which you would manage as normal standalone readers. However, the anti-passback would be controlled by the controller, and you'd never need to talk to the controller ever again. Obviously, if somebody goes in when they should be out, you'd have to let them in through the back door and let them continue with their process again. So in summary, with non-F18 devices, you will indeed need an external controller with a Wiegand interface to manage anti-passback, and you must ensure that the enroll IDs data are enrolled both on the IDs must be both on the biometric side as well as on the controller itself, to make it consistent so that everything works. So that's just a quick summary on how this works, and also a bit of insight and training for people that are installing ZKTeco products, to understanding that for anti-passback you do need an external controller, and as far as I'm concerned, you can use the cheaper controllers which are for tags only, which is the C3, or you can use the inBio Pro or the inBio. It makes no difference because the Wiegand compatibility is the same. And in fact, you could even use a Impro controller if you wanted to, because I've done it in the past. I can remember very clearly we had an access control system at Albert Tutti Hospital, and they kept using the access control system they had in the past 20 years, and we just installed ZK readers as the tag reader, and we could use face, finger, or anything else connecting to the Wiegand interface, and they used a system there, it just escapes me now. I recall now the access control was a Schneider electric access control system, which had already been running and operational for about 20 years. And we basically upgraded it with ZKTeco readers, but we left the back end to still run on their old controllers, and it run perfectly. So like I say, if you've got an existing client with a complete system in place with all the wiring and everything else, which is like a double network of Impro, you can basically just use the ZK reader as your interface.